Okay, hello, good morning, everybody. I'm Cristian. This work is co-authored by Olympia and me. It's a pleasure for me to be here with you. Although I am terrified. Sorry.
Why?
No. Sorry. Thank you. Okay, so first, on the schedule, the title of the presentation is some different, okay? But don't worry, the content is the same. But it's, okay. So the title is Information and Communication from a Manipulated View. So the aim of this work is to argue that is to argue that it's possible to hold a physical interpretation of information in the quantum world. Particularly, we want to offer some insight or some solution to some conceptual problem that the physical point of view has to take it on when we want to talk about transmission of information in the quantum context. Okay, let's start. Okay, so the content of this presentation is as follows. In the first place, we will distinguish two different approaches of information and different contexts where we can talk about transmission of information. In the second place, we will characterize the communicational context. Next, we will lay out two classical interpretation of information: the semantic one, the epistemic one, and the physical one. Okay. And next, the relationship between communication and conversation is really simple. And next, in order to link information with causality, the manipulability view will be looked over. Finally, we will offer our conclusion. So, you know that information. Okay, swarm. Sorry. Okay, you know that information is everywhere. On the one hand, it's a everyday concept that permeates our life, but on the other hand, it's a theoretical term that is used in many scientific and formal theories. So, we could hardly find a single and unique concept that satisfies all these uses. But we do distinguish two different approaches, at least. Here there are mainly two, the semantic one and the statistical one. According to the semantic approach, information is something that carries semantic content. So take this into consideration notions like meaning, truth, or representation. When we say that A has information about B, we say that A means or represents B. But in turn, the statistical approach doesn't consider semantic content. Information deals with statistical properties of a system or statistical correlation between systems. It's independent of the semantic content. Nothing is said about truth, meaning, or representation. Okay? So, in this work, we will focus on this approach. Within the approach, we can identify different contexts. Here, there are only two: acquisitional context and communicational context. According to the computational context, information is something that can be computed and stored. For example, the algorithmic complexity fits in this context. But according to the communication context, information is something that can be transmitted between 2 points for communication. The Shannon's entropy and Schumacher entropies are the quantities that measure how much information the source or destination has. So fit in this context. So again, we will focus on this context because we want to talk about transmission of information. Okay? Well, we are going to characterize the communicational context. In every communicational context, we can point out 3 elements of it: a source, or destination, and correlation between them. Okay? And we can see that in every communicational situation, we can perform certain actions that modifies the state of destination in such a way that the state occurs at the source can be identified at destination. This is our way of characterize the communicational context, the communication situation in general. Okay, I think that you know very well the formula, so I will be brief about this. But the formula is as follows. We have a source, we have a destination, the source has its state, and probabilities are assigned to each state, the same thing, destination, and we have correlation. The point is that with probabilities and conditional probabilities, we have calculated straightforwardly other quantities. For example, noise or equivocity. Okay, but so we could have different situations. On the ideal situation, the correlations are 1-to-1. So the channel is determined. Although other less favorable situations may be possible. For example, when we have noise or when we have equivocity. In these cases, with the noise or with the equivocity, there are no 1-to-1 correlation. But noise and equivocity are not similar cases. When there is noise, one state of the source can be identified from destination, so one can recognize which state it is. But in turn, when there is equivocity, one cannot identify one state of destination with one state of the source. So, noise is something that we can handle. Right? We can handle. But equivocity, we must avoid equivocity. We must equivocity something bad. But due to the situation, there is an asymmetry in every communicational situation, because that allows us to distinguish source from destination. Okay. So let's move on to the third point. Okay. As we have said before, 2 classical interpretations of information can be found in the literature. According to the epistemic interpretation, information is something that supplies knowledge. Some quotes, McKay, for example, says, "We have gained information when we know something now that we didn't know before." Further says, for example, "Information is a commodity that, given the right precision, is capable of yielding knowledge." But on the contrary, according to the physical interpretation, information is a physical item that can be generated at one point of space and transmitted to another point. That can be accumulated, stored, and converted from one form to another.
Christian, before we go on, do you mean a physical item or do you mean a physical quantity?
I'm sorry?
Do you mean a physical item as in object, logical
Right,
category object, or
okay,
physical
let's see.
quantity?
No, for example, it's said by Landauer, information is physical, that is, information is an entity, okay? It's an entity that is out there in our world, on our world, okay? In this sense.
It can be an entity that has a magnitude that is associated that you can measure, for example. And if you can assign the quantity. And you have items with a quantity associated.
So it's a stuff term, it's a substance term in the sense of stuff.
Let us see.
Yeah.
It's not.
I don't know, I'm not sure.
So this is a discussion.
Okay.
You will see that it's not necessary from the viewpoint.
In this sense, information is I think that Landauer says. But this interpretation has a lemma that is no information without representation. And the point, I think that is the physical interpretation needs a physical carrier. Okay, this is the point.
I'm sorry. This doesn't mean that some people, not many, some people think about information.
Sorry.
Okay.
Okay. Hello. Good morning, everybody. I'm Cristian. This work is co-authored by Olympia and me. It's a pleasure for me to be here with you. Although I am terrified. No, sorry.
Why?
No. Sorry. Thank you. Okay. So first, on the schedule, the title of the presentation is some different. Okay, but don't worry, the content is the same. But it's okay. So the title is Information and Communication from Manipulated View. So the aim of this work is to argue that is to argue that it's possible to hold a physical interpretation of information in the quantum world. Particularly, we want to offer some insight or some solution to some conceptual problem that the physical point of view has to take it on when we want to talk about transmission of information in the quantum context. Okay, let's start. Okay, so the content of this presentation is as follows. In the first place, we will distinguish two different approaches of information and different contexts where we can talk about transmission of information, of information. In the second place, we will characterize the communicational context. Next, we will lay out two classical interpretation of information. The semantic one, the epistemic one and the physical one. Okay? And next, the relationship between communication and conversation is really simple. And next, in order to link information with causality, the manipulability view will be looked over. Finally, we will offer our conclusion. So, you know that information. Okay, Swan, sorry. Okay, you know that information is everywhere. On the one hand, it's a everyday concept that permeates our life, but on the other hand, it's a theoretical term that is used in many scientific and formal theories. So, we could hardly find a single and unique concept that satisfies all these uses. But we do distinguish two different approaches, at least. Here there are mainly two, the semantic one and the statistical one. According to the semantic approach, information is something that carries semantic content. So take this into consideration, notions like meaning, truth, or representation. When we say that A has information about B, we say that A means or represents B. But in turn, the statistical approach doesn't consider semantic content. Information deals with statistical properties of a system or statistical correlation between systems. It's independent of the semantic content. Nothing is said about truth, meaning, or representation. Okay? So, in this work, we will focus on this approach. Within the statistical approach, we can identify different contexts. Here, there are only two, acquisitional context and communicational context. According to the computational context, information is something that can be computed and stored. For example, the algorithmic complexity fits in this context. But according to the communicational context, information is something that can be transmitted between 2 points for communication. The Shannon's entropy and Schumacher entropies are the quantities that measure how much information the source or destination has. So fit in this context. So again, we will focus on this context because we want to talk about transmission of information. Okay? Well, we are going to characterize the communicational context. In every communicational context, we can point out 3 elements of it: a source, or destination, and correlation between them. Okay? And we can see that in every communicational situation, we can perform certain action that modifies the state of destination in such a way that the state occurs at the source can be identified at destination. This is our way of characterize the communicational context, the communication situation in general. Okay, I think that you know very well the formula, so I will be brief about this. But the formula is as follows. We have a source, we have a destination, the source has its state, and probabilities are assigned to each state, the same thing, destination, and we have correlation. The point is that with probabilities and conditional probabilities, we have calculated straightforwardly other quantities. For example, noise or equivocity. Okay, but so we could have different situations. On the ideal situation, the correlations are 1-to-1. So the channel is determined. Although other less favorable situations may be possible. For example, when we have noise or when we have equivocity. In these cases, with the noise or with the equivocity, there are no 1-to-1 correlation. But noise and equivocity are not similar cases. When there is noise, one state of the source can be identified from destination, so one can recognize which state it is. But in turn, when there is equivocity, one cannot identify one state of destination with one state of the source. So, noise is something that we can handle. Right? We can handle. But equivocity, we must avoid equivocity. Because equivocity is something bad. But due to the situation, there is an asymmetry in every communicational situation, because that allows us to distinguish source from destination. Let's move on to the third point. Okay, as we have said before, two classical interpretations of information can be found in the literature. According to the epistemic interpretation, information is something that supplies knowledge. Some quotes, McKay, for example, says, "We have gained information when we know something now that we didn't know before." Further says, for example, "Information is a commodity that, given the right precision, is capable of yielding knowledge." But on the contrary, according to the physical interpretation, information is a physical item that can be generated at one point of space and transmitted to another point. That can be accumulated, stored, and converted from one point to another.
Christian, before we go on, do you mean a physical item or do you mean a physical quantity?
I'm sorry?
Do you mean a physical item as in object, logical
Okay,
category object, or
okay,
physical
okay.
quantity?
No. For example, it's said by Landauer, information is physical, that is, information is an entity. Okay, it's an entity that is out there in our world, on our world. Okay, in this sense.
It can be an entity that has a magnitude that is associated that you can measure, for instance. And if you can assign the quantity. And you have items with a quantity associated.
So it's a stuff term, it's a substance term in the sense of stuff.
Let us see.
Yeah.
It's not.
I don't know, I'm not sure.
So this is a discussion.
Okay.
You will see that it's not necessary from the viewpoint.
In this sense, information is I think that Landauer says. But this interpretation has a lemma that is no information without representation. And the point, I think that is the physical interpretation needs a physical carrier. Okay, this is the point.
I'm sorry. This doesn't mean that some people, not many, some people think about information.
That's Schumacher's phrase, no information without representation.
Schumacher, I think that
I think Schumacher invented
somebody before, I don't remember.
I don't know.
Supposed that Landauer was, I don't remember.
Steen says it
Yes.
in 97.
Yes, I think it's very,
Andrew Steen.
I'm searching. Pretty sure that
Schumacher has this on his wall, the Bill of Rights. Something like
I'm sorry. Okay, but both interpretation have some problems that are worth pointing out. Let's start with the difficulties of the epistemic interpretation. Okay, so let us suppose that the entropies and mutual information represent, that is, the node, measure, and so on, knowledge. So, we can ask, what about equivocity and knowledge? Do they represent knowledge? Okay. Well, look at the two possible answers. If we say yes, it sounds strange that what hampers communication denotes knowledge. But if we say no, it sounds strange too, because the magnitude that measure different items participate in the same mathematical operation. So it would be to subtract apples from oranges, for example. Okay, it's something great. So another case of difficulties of epistemic interpretation. Let us suppose a radiating antenna that sends signals. And furthermore, we have two TVs that receive the signal. And there is a strong correlation between two TVs. So, one can know what happens in one TV by looking at TV1. But although there is no physical link between them, okay? So the situation is as follows. There is correlation between antenna and two TVs. It's obvious. There is communication between antenna and two TVs. It's obvious too. And I think that there is communication and causation between antennas and TVs. But the question is, okay, there is correlation. There is strong correlation between the TVs, but is there communication between TV1 and TV2? Is there a causal relation between them? So, from the epistemic point of view, we must say yes. For example, Frederick says, from a theoretical point of view, the communication channel may be thought of as simply the set of dependent relation between S and R. If the statistical relation defining equivocation and noise between S and R are appropriate, then there is a channel between these 2 points, and information passes between them, even if there is no direct physical link joining S with R. However, nothing can be done at TV1 to modify the TV2 in the state of TV2. So it's obvious that, for example, if we turn off one television, nothing happens at an R1. But in this way, we have characterized the communication before. So there is a serious problem for me. So there is no communication between TV1 and TV2, but according to Dreske, there is communication between TV1 and TV2. So
it might be worth noting that Gretzky modified his view afterwards, so he came to say that actually it's about counterfactual dependence, not to do with perfect correlation.
Thank you. So, now let's move on to the difficulties of the physical interpretation. And I think that everybody knows the teleportation protocol, so I will read about this. But these difficulties arise in a quantum context, okay? Particularly in the teleportation protocol. I do know that an unknown state is transferred from Alice to Bob with assistance of a short particle in a time system and of 2 bits of the transfer. So the question is, how does information get from Alice to Bob? Well, Kernel offered an answer. He said that the only other link between Alice and Bob is the quantum link that the intended pair provides. In space-time terms, this link extends back into the past from Alice to the event at which the intended pair was produced. And then it extends forward into the future to the event where Bob performed his operation. And this is the point. There is no other physical, there is no other physical connection. Okay? This is the work of Fermat. But, of course, there are other answers, for example, Josa, but I want to stress the position of Deutsch and Heidel. They say that the information is hidden in the classical bits. So this is another answer. But we think that these solutions are a little bit artificial. Okay? For example, they commit us to claim that travel to the past are possible, and it's something spooky. So we claim that teleportation leads physical interpretation to artificial solutions. Okay, the teleportation is a physical case. Okay, it's a physical case that the physical interpretation doesn't solve. Okay, and that is the challenge for this interpretation. Okay, but at this point, we can adopt a third way. Okay, we can adopt a third way. As the epistemic interpretation and physical interpretation have serious difficulties, we can adopt a deflationist point of view that cuts the Gordian knot. Okay? Cristian says there is not a question of information being a substance or entity that is transported, nor of the information being a reference term. Okay, that is a good point, and it's the usual way that we solve problems in philosophy. Okay, it's a good point. But, I'm sorry, I have some remarks. It's not so easy for me to understand how, from this point of view, one can deal with the way of engineers measure the velocity of transfer of information. Okay, they measure the velocity in bits per second, where sex refers to something that is physical, and bits refers to something that is not physical. So we think that the challenge of the physical education is worth addressing, okay? And the problem, it can be put in these terms. Is there a way of preserving a physical interpretation of information without need of a physical carrier that travels through space? That is a challenge for us. That is the challenge of this presentation. Okay. So we think that only tell me, think that some insight could be found if we examine the relationship among communication, causation, information, and manipulation. Okay. In the first place, as we have said before, communication requires that what happens at source produce what happens at destination. The very idea of producing implies causal notion and certain asymmetry. Okay, there are a lot of theories about causation. Okay. The two main general is counterfactual and physical theories, but we don't consider the counterfactual theories because we want a physical theories about causation. But the physical approaches offered so far demand a physical carrier, a physical carrier that links the cause of its effect. And we need something that's different. Okay? So, we will be a little bit pragmatist in this part. And we'll take one account of causation that we think that could work well for elucidating our problem. And this account is the manipulative account of causation. Okay, the early versions of manipulability involve causal terms that need to be reduced to non-causal terms. The concept of free agency is fundamental for this account. Some quote from Wright, for example, says that to think of a relation between events as causal is to think of it under the aspect of possible action. More recently, Menzies and Price say an event A is a cause of a distinct event B, just in case bringing about the occurrence of A would be an effective means by which a free agent could bring about the occurrence of B. But this early version have the target of some criticism. Some people says that the account is circular. Okay, bring about, produce, and so on are causal notions. So this clarity is a very serious problem. I don't know, the Heideggerians don't care about this, but we do, no?
Can you explain that? The Heideggerians.
Heideggerian. Huh?
Hegelian
Okay.
Hegel.
You can live with contradictions and
No
no problem.
problem.
Oh.
Hermeneutic circular. No? Circular hermeneutic.
Circular.
It doesn't matter. It doesn't matter.
It's philosophical joke.
That makes me laugh.
Okay. Okay. Another criticism is this. The manipulated account in these early versions doesn't include cases not related to human manipulation. For example, the movement on tides or the moon. Some criticism, okay? But however, there is another version of manipulability. That is the interventionist version. That doesn't intend to define causation, but to delimitate the domain of causation, where causation is a primitive notion. The main concept of this version is the intervention. Okay, but what is an intervention? Woodward says that an intervention on x with respect to y changes the value of x in such a way that if any change occurs in y, it occurs only as a result of change in the value of x, and not from some other source. The idea is very basic. If we want to manipulate y, okay, we can intervene on x, and something must happen on y. Okay, very simple. But as we can see, the interventionist version is not circular because it doesn't intend to give a definition of causation. Okay? Neither is an anthropocentric account because admits possible interventions, not only factual intervention like the early version. But Nancy Cartwright have a criticism. And she says that the intervention version is an operationalist approach. She said that it leads to withhold the content of the cause from a situation that seems the same in all other aspects relevant to this application, just because our test cannot be applied in that situation. Keep in mind this. So, going to the relation between information and manipulation. Okay. Going to this. And we claim that from the interventionist account, we can correctly identify transmission of information from a physical perspective. This is our point. For example, if we take the classical model of the antenna and two TVs, it's very easy to see that if we intervene on the antenna, we can intervene or manipulate TV2, for example. I don't know, if we destroy the antenna or change some variable, okay, something must happen on TV2. So we claim that, okay, in this case, there is a causal relation between antenna and TV1 and TV2. And this relation is identifiable by means an interventionist account. Okay? The same thing can be said in the teleportation protocol, but we will see that later. And furthermore, we can see that the anthropocentrism is not an issue for this account because in communication, the human always intervenes. Neither the operationalism is a problem because this is not at all embracing definition of causation. Okay? So, things are looking up for us, but there are possible objections from the authors of interventionism themselves. Husband and Woodward say that interventionism is not applicable to EPR situation. What Woodward and Husband says that it's not possible to intervene on particle 1 without intervening on particle 2. Okay? They have assumption of this. They assume of this. But there are other positions for this. Okay? Mauricio Suarez, for example, distinguishes between non-separable state and non-separability of events. He says that whether interventions are available in EPR and quantum mechanics in general is a complex and contextual question that doesn't have a unique or uniform answer. So we don't want to drop out the interventionism due to this objection because there are other positions about it. No, the holism is not the unique position. Anyway, teleportation is not a mere EPR experiment. Look at the teleportation protocol. We have an entangled system that Alice wants to transfer to both information. Okay? But we can, from the interventionist version, we can intervene on Alice, on the state that Alice has. For example, we change phi by C, so Bob get C and not phi. It's obvious. Okay? This is a way of intervene on the situation. But we intervene on the classical channel that transfer 2 bits between Alice and Bob. Bob wouldn't get any information if, for example, Alice sent 1 bit instead 2 bits. Okay? Okay. So we can understand teleportation protocol a physical situation where the information is transmitted. So considering teleportation in informational terms makes sense. Makes sense if we use some causal notion from an interventionist point of view. Okay? This is our point. So our conclusion is a sort of lemma. Okay? No information without manipulation. Thank you. Hold on, I don't know if Olympia wants to say some words about the mountain and murder in New York State.
Perfect correlation. I mean, what we want to stress here is the difference between correlation and association, and that we need something more than mere correlation to have information in a communicational context. Yes. First, second,
It seems perfectly sensible to distinguish between communication and having information.
I don't see the TV case as being especially problematic, as saying, well, one TV does have information about the other, and there's a straightforward sense in which that's true. But I also wouldn't want to say that there's somehow communication between those two. And one way to make the distinction is to rule out some kind of manipulability condition. I think two things to just mention about that. Manipulability theory is a counterfactual theory.
Sorry, what?
The manipulability theory of causation is a counterfactual theory. So I don't know that that's a useful distinction to make. And then the other thing I wanted to ask about is, I mean, you're obviously having some problems using Woodward's formalism, and it's precisely because when you call for an intervention, something can only count as an intervention if other things are held fixed. And it's impossible to hold other things fixed in the scenario. So, I mean, why do you even need Woodward's apparatus in order to make the distinction between information and communication? Why not just say, why not just a simple counterfactual criterion there? Look, if I would have done something different at one end of the communication, then something else needs to happen. And I just don't see the need for extra apparatus. So if you could tell me why you need that, that would be great. And then the second thing is that it seems like most of the talk was about that distinction. I don't see at all how that supports any sort of physical view of information.
Let us begin with the first one, because I don't know if I understand the second one. But the first one is why we don't use counterfactual causation, because we have no physical theories of counterfactuals. But we can have some physical tests about interventions. So if we want to have, if we want to retain a physical, in a sense that I suppose that we will explain in the next question, in a physical view about information, I need a view of causation that can be supported at least empirically. And it's very difficult to have a physical or empirical account of counterfactual. This is the reason why.
I understand the difficulties in defining truth conditions for counterfactuals generally, but surely you don't mean that we don't have empirical evidence of the truth of certain counterfactuals. I mean, that's exactly what the Woodward apparatus does for us.
Yes, of course.
Here's where we have good information about when certain kinds of counterfactuals are true.
The fact is that when you supplement the counterfactual view with other conditions for the truth of counterfactual that comes from empirical and physical ground, I think that it is not a merely counterfactual theory of causation anymore. This is my sense. I mean, let us see it from the other side. I'm not saying that you cannot say, if this would happen, if this happened, the other thing would happen, and that is forbidden. No, of course, but I think that the counterfactual theories of causation have all these, all these apparatus of possible worlds and modifications of things here and there. Well, this is something that is so far from what I think that we need for a physical account of causation that I don't want to hear about that. This does not mean that I can have another reasons to ground counterfactual claims. This is the difference, I think. This is the way why we don't want this kind of counterfactual theories. You know, the tradition. Well,
I understand the suspicion about the metaphysics of counterfactuals and you not wanting to get involved. I don't think Woodward helps you with that. I don't think Woodward helps you get around the avoidance of that sort of thing. I mean, it seems to me perfectly sensible to just say, I don't have any deep commitments to why certain counterfactuals are true or not. But what I do want to use is the truth of certain counterfactuals to determine when I have communication and when I don't. And I mean, that's what Woodward is doing. I mean, the worry is that you're buying into all this machinery you don't actually need to do these things. And this is problematic because, look, the hard thing to do is apply Woodward in this case precisely because you never meet the right conditions for intervention. Because you can't hold everything fixed. And this is the problem about why Woodward's apparatus just doesn't tell you much about anything with respect to EPR correlation. It's because you can't apply it. You can't hold certain things fixed. And the thing to do in that circumstance is, of course, some sort of like causal agnosticism, because his theory just doesn't apply to those certain sort of circumstances. But again, I don't see why you need all that stuff. It seems more trouble than it's worth, is the point.
Well, okay. Perhaps you feel that it's simpler counterfactual causation. We like this one for two reasons. One, the first one I told you,
Yeah.
and the other one because it is not definition. That's not intent to be a definition.
We don't want to know what causation is. Okay, we want a tool that
to identify.
Yeah, I mean, you've got the tool without all the nonsense that Woodward has associated with it. I'm giving to the tool here, and you're saying,
The tool is counterfactual. Well, I'm. If you take somebody who defends counterfactual causation, we say you that you have to know the conditions of the possible worlds. Well, I mean, counterfactual from a very intuitive way, it's okay, but it is not a theory of a causal, counterfactual theory of causation. I mean, normally, counterfactual theories of causation came with all the apparatus of a possible world. Of course, we can use counterfactual in an intuitive way, but it is not what we are looking for. I mean, well, of course, we can.
How about the second question? So, in what way at all does making the distinction between information and communication, regardless of what resources you use to make it, how does that defend in any way, shape, or form some kind of physical view of causation, or physical view of information? I don't understand the connection between those two.
But we are not looking for a difference between information and communication. We are looking for a characterization of information that fits into a view of communication. In communication, the idea is that you have to have some control of the source to obtain some result in the destination. This is why the two TV sets are normally, from a communicational viewpoint, and I mean communicational in a sense by Shannon or by Schumacher, that this is not communication. This is not. If I don't have communication, I have no transmission of information. I can have something. Okay.
I completely agree. Now, how does that get me to a physical view of information?
Well, but this is this is an answer because you said from at the beginning. Well, but I can have the two sets in a certain sense. I can have information between them, not from a practical viewpoint, not from an engineering and communicational viewpoint. I think this is one thing, and the other you said why I need this view. I want to let us suppose that we want to distinguish clearly. That I think that is the main point. We want to distinguish correlations from something that said Rob the day before yesterday. Correlation from causation. But when we enter there, we have we run the risk of changing one notion by another, even more obscure notion as causality. So the best way is to take some pragmatic notion, even not a notion, not a definition, we are not trying to explain causation in all possible situations, not causation as the very nature of causation, but to have a tool to say, here I have causation, here I have not causation. And this is the reason we use this kind of pragmatic view. And our sense is that the criticism to this view are criticism directed to a position that is thought as trying to give a whole-embracing definition of causation. If not, I think it's okay. If you accept that this is not a definition of the nature of causation, I think that it works.
So we're back to the first problem now, and what you're saying is you need a sorting mechanism, and I'm telling you you've got a bad sorting mechanism.
A what?
A sorting mechanism. You need to sort communication from something else. And I'm telling you it's a bad sorting mechanism because Woodward's apparatus doesn't apply in this case. You never get the interventions that you need in order to determine whether there's causation
because you say
or not.
that all the other conditions are not, you are not sure that all the other conditions are fixed.
I'm sure they're not. That's the problem. You can't ever get the apparatus to work. So if you're looking for a sorting mechanism, and however you want to put it, information, communication, causation, correlation, you're not going to get it in this circumstance precisely because you don't have an intervention.
Perhaps,
according to Woodward's system. So the system never applies. You never get the sorting that you want.
okay, perhaps we have not understood Woodward's view correctly, but the idea of intervention is an idea basic in the use of communication.
Not in Woodward's sense. Not in Woodward's sense, where you have to hold all other variables of interest completely
You
fixed.
have to, but
And
this
Woodward needs that
makes no
stuff.
sense. You cannot make the whole universe fixed.
That's
If
right,
you-
and that's why it's a counterfactual theory, right? You counter...
You can assure.
I'm not
you
going to
can
push this
have-
anymore.
I mean,
We can-
no, but it's interesting because from a physical viewpoint, if you want, from an engineering viewpoint, you don't need to have the whole universe fixed. You only need, in the light of a relevant, theory, that the relevant variables are fixed enough, and so you will have communication. But for that, you have to move here and have an effector there. Of course, the moon is moving and all this.
That's not the point. It's not about holding the entire world fixed. It's about fixing a certain set of variables of interest. So
Well,
in any case, I think
let us see. No, we
hit
will
the
see.
terminus of
No,
fruitful
okay, we
discussion
will
right
see
now.
again this proposal. Perhaps we have to change, or we have to modify what they exactly say, because we have interpreted it from good viewpoint, I mean, with good lens, and perhaps we can have to say, okay, if I take this manipulability view textually, it's not applicable, but it should be reinterpreted in different terms. Perhaps you are right. No, sorry.
So, first let me say, Christian, thank you for a very clear talk. Second, I agree with everything Ari said, I think. Third, let me add some points of my own. So, I really like the slide where you had the worry about the speed of transmission of information and the bits on top and the second underneath and one was, you were saying one was physical and one wasn't. But we need to be a bit more careful here. So it's part of the way that I'm trying to present things that we distinguish between pieces of information and information as a quantity, something which is measured by the Shannon quantity or by the Schumacher quantity. Okay? And I don't have any problem with saying, and certainly in that 2006 paper and later, I certainly don't say that the Shannon quantity can't be thought of, or the Schumacher quantity can't be thought of as a physical property if you want. So if your probabilities are suitably physical, or if your quantum states are suitably physical, and you can just have a function of those things, sure, call that thing a physical property if you want. Of course, it might be what kind of physical property is it, or how does it behave, how does it compare to others, that's a separate question. But it's not part of the picture that what is measured by number of bits is not a physical property. So there isn't, at least in my picture, there isn't a worry there. And so then what are we left with at the end of this, at the end of the story?
Can I, well, let me finish, because I think that I think that I'm feeling these days, and finally understanding where the point is.
So, as we cut into the chase, we had the numerous stories saying, look, here's something interesting that's happening to have communication of information, or quantum information in the teleportation case, because varying the state inputted over here produces a variation in the state outputted over here. In fact, it's perfect identity, the very same state. And so, and indeed, you could say, fine, I mean, that's not what I'm seeking to rule out. So I don't deny that there's information which is produced at the source in teleportation and which is then reproduced at the destination. There's the question, how did the information get there? And the claim is, well, not by flowing in any spatiotemporal continuous manner. And why should we expect it to? Well, we're talking about pieces of information. Pieces of information aren't kinds of things, so they're not spatiotemporal locatables. Then maybe is there a question of something like, does the information quantities that we're talking about have to obey something like a local conservation law? Or why on earth should they? And in particular in quantum mechanics, you're going to, we're not going to say there's anything like that at all. So, at least the way you're setting things up, I'm not sure that you're responding to I don't think you quite characterise the view that I'm trying to articulate properly, so I don't think there's actually a worry there of the kind that you're trying to offer an account of in response to.
Well, I think that now I'm understanding the point, and the point is not, I mean...
Should we let Cristian know? Should we let Cristian say something first? This is his first talk, so he was really terrified. So he's done a great job. Yes, of course. You want to? Well, then he will add something. I think that the fact is that what do we understand by physics? When we are looking for a physical view of information, it's not that like that is a kind of stuff or something like this, or an object or an individual. Not at all. So, what is physical? It's something that it is subject to the interest of physics, and in a certain sense, it is there in the world. We don't know which is the ontological category, but perhaps, or it's ruled by physical laws, and physics decides, or will decide, or finally in its own development, will make it or not a concept of something that is there in the world. When you take this position, so the problem is not if it is a stuff or not, but it is if it is something that has been studied by physics and
so in certain sense is there. And what we think is that we have not to decide a priori. We have not to give an answer a priori. If physics is now conceiving information in this physical way, perhaps it's a very interesting way in which physics will develop, just finding a very all-embracing concept, absolutely abstract. It's not something that we can touch. Okay, but this does not mean that it's physical. It's not physical. It does not. It is not subject to a conservation law. No, and position, velocity are not subject to. Are properties not subject to a conservation law, but they are physical. They seem to describe something that happened in the world in a certain sense. The other day, I think that, I don't know if you were talking about the capacity of something that is physical in a certain sense, even if you don't touch it. Entropy.
But I don't want to deny that information or quantity can be thought of as a physical quantity. Okay, so I don't want to deny that. But are you wanting to say that you just wish to remain neutral about, when you say that information is physical, that remain neutral about whether you're talking about particular or a stuff or a property, or do you think it's none of these?
We could. My sense is not that it's not a stuff in a sense of.
So it's not a stuff. So it's
but,
particular.
but it's no. Maybe something like a property or
Okay,
something
fine,
like
fine.
it's something like different. Perhaps it's something that does. For instance, in a very wonderful book of John Ehrman about space-time relativity, he says perhaps our traditional categories are not enough to give sense to this kind of new entity. I don't know. I mean, this is the final answer about the ontological category of information is not something that we want to decide now in general. We want to decide now. And perhaps it's not something that will be decided by philosophers. Philosophers will elucidate how the concept of information enters and develops in physics. This is the point.
So the claim boils down to then that you're wanting to defend the claim that information as it features in information theories, quantum and classical, is something which physics deals with.
Yeah.
And you don't wish to be committed any further to any characterization beyond that.
Ontologically, but it's something that can be there in a certain sense that we will not decide now, but it's there in the world.
Thank you. I mean, I think
You don't agree. You don't agree. I know that.
No, we don't disagree that physics will deal with it. It's just I think we need to be more precise. But hey, let's. So we're doing Christian. Did you want to add anything?
A ver,
Decirle un poco en español, si no
Ah,
se lo
okay,
claro.
okay. I don't know how to think about the relationship between being physical or being a substance. Okay, I have the intuition that if you say that the information is not physical because it's not a substance, so the physics doesn't talk about physics things. Okay?
So I wouldn't say that inference follows.
No, this is my intuition, but I think that the physical point of view doesn't commit with a substance. Okay, we have substance for things. Substance in Aristotelian terms.
This is another distinction.
Okay.
Not one thing is a stuff, and another thing is
A
a substance in philosophical.
Primary substance.
yeah, okay, Aristotelian terms of substance is I don't know how to say.
Substratum.
Substratum. Okay,
Where
where the properties
Where the properties inhere.
inhere.
Inhere or something
Okay.
like this.
Okay, this is another situation. This is one situation. But I think that it's physical in the sense that the theory physical talk about these things. I don't know.
And we
This is my
suppose
tuition.
that physics, well, not we, not Chris, but we think that physics talk about what happened in the world, not cubism, perhaps, but in general, if we think that physics talk about what happened in the world, well, the physical things are there in a certain sense.
So I'm not denying that physics talks about things that happen in the world. I just want to say that there are some very simple logico-grammatical, ontological categories that one can help oneself to. And perhaps you don't want to be committed, and that's fine. But I think that's probably characterising the difference between us. I think that's perhaps all that matters.
We agree in our disagreement. Another question?
Oh, I have a question at the very beginning. I have a question now. What is the difference? I mean, it's a naive question, sorry for that. What's the difference between an object, an item, and stuff? And, I mean,
Yeah.
I have an iron in a drop, within a drop. Is that an object? It's a stuff. What is this?
It's an object.
It's an object. Good. Give me an example of an item.
Item and object I would use pretty much interchangeably.
Sometimes I use item when I don't want to say if it is an individual, a property, a stuff, or it's an item,
Yeah.
something that is there but I don't know what it is. So you say an ontological item, something that exists. In my case, I have no another more general word to don't remain stick to a category.
It's helpful to address things at the grammatical level. So objects are picked out by proper nouns, stuffs are picked out by mass nouns. So something like butter, water would be a mass noun. If we say water, so we add to the mass noun, so the participle that allows us to refer to a particular one.
You can count individuals or objects. You cannot count stuffs. You have not many waters or many. This is the difference, and in general, it's thought that there is some ontological difference regarding the references of those kind of. Not always, because if you are a real reductionist, I mean, physicalist reductionist, you will think that all reality is made by elemental particles which are objects. So stuffs in reality that are aggregates of individuals. I mean, it's not necessary to. You can make the difference conceptual, you can have the conceptual difference in your mind, but anyway, to think that in reality there is only one kind of item of reality, I mean, not stuffs, but only individuals, or not individual and only stuff.
Wheeler positions claims that the information is a stuff because it's a subtract all reality. It from bit, okay? Always, all things from the bit. But
No.
we don't say anything.
No, we don't say either that everything is energy, or everything is charge, or everything is mass. I don't know. There are many different.
I think that information is like energy, okay? This is
informational intuition. Okay, and information is like energy, another quantities that physics talk about.
And we have no idea what energy is. I mean, we are very we are very sure. We are not as sure. But
I'm sure, but in Spanish, in English, I'm not sure. in Spanish, I'm very sure. In English, I don't know. I don't know anything.
I just wanted to ask one more question, and I won't intervene at all, I promise. So, if your position and Chris's, and probably mine too, are totally compatible, what is the motivation for being agnostic? Completely agnostic here. So information isn't a stuff, but it's physical, but you don't want to say anything more about it. Why?
I'm not saying that it is not, that we cannot by principle say that. We are agnostic now because perhaps we have to continue our research, or perhaps we're talking about that the day before yesterday, or perhaps it is, in a relative sense, it's a new concept entering physics, and physics is still not decided. I mean, there are positions that see information in one way, and there are other positions in another way. I mean, I think that perhaps it is a philosophy. Let us suppose with energy. We can discuss from a philosophical viewpoint which is the ontological category of energy or space-time. I think that it is an open problem. But energy or space-time in physics, you have no discussion about how to handle, how to use it, which kind of a physical entity is. So I think that this is not the situation with information now yet. So let us wait how information enters the world of physics. There are physicists, for instance, I told you, Carlo Rovelli is convinced that information will follow a way will have a similar development similar as that of energy. But, well, we don't know. Okay, thank you. Do you want to answer some questions about yesterday? Not yesterday, the day before yesterday. We forgot everything, but I have a question.
I'm happy to leave it all forgotten.
Oh, but, well, I can ask you later with the sandwiches.
Okay.
Okay. So we can go to have an early, not so early.